Okay, now we will start with write function, and mainly our function as a first, it's write. Okay, our function write inside a file. So if you want to have a file, if you have a file and you want to write something inside this file, you can use write function to write inside this file. Okay, and let's take a look on the requirement. We said before, any function, if you want to use it, it has some requirements. So as a first, it's size t, right? And this our container, and this container like holds the result returned from the function. So it's a container for holding the result back from the function. Okay, this is the first thing, and it is the type of size t because the result returned from this function, it is the number of bytes written. So because that is size t, the first parameter for this function is int fd, and fd, what is the meaning of fd? Is a file descriptor. So what is the file descriptor? File descriptor is like an ID for the file. What does that mean? Like it's like your national ID returning some information about you, and ID for the file, so it has some information about the file. Okay, so the first parameter for the write function takes the fd. So maybe our question now, how can I get fd? Okay, if you want to write inside the file, you have to open the file at the first. So we will use our open function, and the returned value from open function is fd. So our first parameter inside the write function will be the returned value from open function. So it's a returned value from open function. And then buffer. What is the buffer? The buffer, it is like temporary container for the character. What does that mean? Like, let's come here and say, if you have here your write function and here your memory to store what you should write. Okay, uh, like it is not like directly from here to here. Like you have must write, you want to write hello or h, it's not directly comes from your write function to memory. Okay, what is happening here? What is happening here is like you have a middle container, our middle variable. This is variable or container called buffer, and what is mainly do? It's just holding the value like hello or h. This value is holding in temporary, and then it's like deliver it for your memory. So your function either write or read or anything else, not directly interact with memory. It just like put the value inside a container, inside a buffer, or inside a variable temporary, and then it deliver it to the memory. So here we have our temporary container, which is a buffer to hold the character temporary. Okay, and the size t count, it's to count the number of character to be written. So it's our container, other container to hold the number of character to be written. Okay, so this is our three parameters and our container to hold the result returned value or the result from the function. Return value, we said that returned value is the number of bytes on success, the number of bytes written, but on error it returns -1. Okay, so what like our question, here's the question, what do we need to use this function? What do we need? We said that the first thing is like variable to hold the result value. So variable to hold the result from the function, and it will be size t type. The second is fd, and we will get it from open function. The third is a char or pointer variable. Let's say that pointer variable to hold the characters temporary, and the fourth one like variable to hold the number of characters. Okay, so let's try to make like see the codes or to write the steps to make our code. So the first thing we said we will like we will call open function to open the file before write inside it, because we can't write inside the file and we didn't open this file from the beginning. So we have our open function, we should like use it and call it. So because we won't use this function, we should look at its requirements. So basically the first thing it needs like int fd to have the return value of the function, and the path name. We don't have to open a variable for the path name, we just can write it like this inside the function itself. And the mode, and also we don't have to declare any variable for mode. Okay, then the buffer, so char pointer buffer, and the counter of course, so size t count counter, then size t result to hold the result from write function. So then we have to call open function and check for errors, and then call write function and check for errors. And we will not do anything with data, we just like we can print bytes written and then close. Don't forget to close the file and then just end the program. Okay, so let's try to write okay vi right to write the code. Let's look at the library. This is library for we set for write function, so we should take a look on libraries for open function. Okay, int main, then int fd like we said, char, okay, char pointer buffer, buffer will equal, I will just will assign what I want to write inside the file. Here hello world from C. Okay, and then size t count. Count we said that is the number of character we will write. Okay, so here will assign number of character we will write. So I will say string length, this is function, and we'll give it buffer as a parameter because it says string length of buffer. Okay, and then size, okay, size t, and the size t is the result to hold the result from okay from write function, but we can say bytes written to be more descriptive. Okay, so we will call our function open function, so fd will be equal to open, and we will open a file exe like example.txt. This is the path name or the name of the file. And the second thing, like the mode, okay, we want to write, so write only mode, but I can combine other mode like create, which mean if this file isn't exist, just create it because we don't have this file. And outrank, like if this file is exist and has some values inside it, so there's something inside this file, just like rank it. Okay, and this is right, this is number for the permission of the file. And then we will check if there is any error. So fd -1, that means there is an error and it can't open the function, open the file. So b error can't open, and return 1. And then we will call our write function. So byte written will be equal to write, and it will take fd, then buffer, then count, and then we will check for error. So if bytes written equal to -1, I think that's true. Okay, if equal -1, so print error can't write, and we open the function, so we have to, sorry, we open the file, so we have to close the file, but then we have to put return 1. So if there is no error, so we just can print f bytes written equal, because we just want to write, like print bytes, so we put format specifier zd, and then bytes written. Okay, and then we will close the file and in the program, and then we should compile gcc write.c -o write string. Oh, of course, stdio. Here, right? Okay, bytes written is 19, and that's it for this function. And second function with us here, it's like signal function, but I will not use like man page because I just extract some information and make it simply and write it. So I will not like look at here, I'm just look at here, and we will like break everything down. So at the first, our function called signal, and it like signal handling, and we will talk about this now. Okay, the first thing is the explanation. Your program always receives signals. You can think about the signals like a notification on your mobile. So if you have many notifications now on your mobile, you have like 3 options to handle or deal with these notifications on your mobile. The first option is like maybe you can answer all notifications, answer all of them. It's like maybe it's like a default option for you. It's like to answer everyone, or to ignore everyone, or to handle this notification. How to handle, like you can answer some of them or you can ignore some of them, and you can do something else like this. So handle, it's like variety of actions, or you have to action answer or ignore, and the third one is handle of them. Okay, so our here, like our program always receives signals. These signals, you can think about it like notifications on mobile. When you think, are you going to ignore or answer or handle them? It's like your function here signal, because your function signal function control how the program will respond to this notification. So you're thinking about this notification, it's like the signal function. Okay, and you maybe, like I said, have three actions to ignore them, or default action is to answer everyone, or different action depending on the notification themselves and who sends this notification and how are they important and things like that. So we will create function, and this function called the handler function, and this function like basically will try to handle this notification depending on what you want to do with this notification. Okay, so let's here there is a note, like we if we go back here to this like prototype of the function, we will find the parameter of the function is like a function pointer. Okay, if we just go back to function pointer and we will try to remember what is a function pointer. um, Function pointer, any function by default, any function or any system call by default, um, it takes variables as parameters, only variables, not functions. Okay, so I mean by that like int add, int a, and int b. So our function takes variable a and variable b like a parameter for it. Okay, so but we didn't create a function with int add and put inside this function another function. Okay, but what if we need to put a function as a parameter inside another function? So here instead of have a variable you have a function. That is mean you put a function as a parameter inside another function. Okay, what if we need to do that? If we need to do that, we should in prototype, like here in our prototype, to have a pointer function as a function, sorry, a pointer function as a parameter for this function. What does that mean? It's just a pointer variable, just like it's holding a place for another function. So I take a chair, and like it's set on this chair, and it said like it's my chair. When one will take it, no one will take it, and when the function you want to call come, it just lifts the chair to this function. So it's like a reserve place, a place for the function as a parameter for this function. So now you can call another function as a parameter inside your function. So signal takes a function as a parameter for it. Why? Because in its prototype it have a pointer function. And what is a pointer function? It's someone like we in university or in our school. We always like say to our friend, if you will be late in at your lecture, or we will be late at the class, you just reserve a place next to you for me. We always do that with our friends. It's like that. So pointer function reserve a place for the other function until it come. When it's come, it just give it the place. Okay. And the second, the prototype here, it's like a signal, and like it takes the signal and the function itself. Signal here is like standard signals. We will look at them. Okay. So this is not just like our prototype of the function have the function pointer as a parameter, and this function pointer allow us to use another function as a parameter, and we can call this function because of the existence of function pointer inside the prototype. Okay, I said here by default any function takes variable as a parameters. Uh, what if we need to pass another function as a parameter, not just a variable? For this, we have our function pointer, and function pointer reserve a place as a parameter to the function. So if you want to call any function as a parameter in your function, you can do it. Okay. Here's the most common signals we can use. We said here, the second prototype, you have signals and you have your function. Okay. So the signals here, like this signal is typically generated by the user pressing Ctrl C. It is used to interrupt or terminate the process. The default action is terminate the process. And you have another signal here. The signal is sent to request termination of the process too. And you have sig hop. The signal is sent when controlling terminal is closed or controlling the process terminates. Sig kill, it's to like used to forcefully terminate the process. okay, and here seg user 1 and user 2 signals are user defined and can be used for application specific purpose. Okay, so now we just have our list of signals. You can look at them. So let's try to like create our function and like write our pseudocode. We said that we will just create our function and let's make it simple and use this function like we will make it so simply. We will not like make a complicated handler function. We just want to know how to use it or how to make our handler function. So basically at the first you will make your handler function before int main. So whenever you use this function and you will use or create your handler function, you will create it outside the main. Okay, then you will start your main function. Inside your main function you will call signal function and give it the first parameter, which is one of these signals, and then you will give it the second parameter. It's your handle function which you created as a first. Okay, and then print anything just for testing, and we will make our while loop and make okay our while loop just to make the program like rest for a while to allow us to like send and receive the signal. Okay, and then return 0 as the end of the program. Let's try to like start our code or make our code. vi signal.c. Let's look at the libraries. H and hash include unistat.h. Okay, we said at the first step we will start our handler function before main. So creation of handler function. Okay, so it's a void because it doesn't return anything. Signal handler, and we will put here int signal, and we just said we will print if something. We will not like make it complicated, so we have to print if received signal is okay, and here signal our parameter. We will close the function, then int main. Here we call our signal function and give it the first parameter. Let's see, we will take which one? Sorry, not here. um, let's take the first one, which is control C. Okay, and we'll give it our function. Okay, and then print if you can say running press control to exit. Okay. Then we said that just we will make while loop to give chance for the program to receive and print the function, the signal. Return 0. Okay, I think it's all GCC signal. Okay, signal. Okay, running, press Control Z to exit. At the first we want to, I will press Control C to know what is the received signal. So I press the Control C and the signal is 2, or like the value of the signal is 2, and I will push now Control Z to end the function, and we will end it. Okay. And now we have the third function, which is a state function. Okay, and our state function first. Okay, a state function, what it does, it's like state. If you want to have the all status or all information about your file, you should call state function. State function return for you like all information about the file, like permission, size, details, uh, any like details and information about the file, you have to call state function. Okay, so what it does, it just like returns all information about the file. Okay, in the state, it is like our container to save the returned value from the function. um, and let's see. Okay, on success it returns 0, and on error it returns -1. So int state, why int? Because it's like our variable to store the result from the function, and the result is 0 or -1. Because of that it's type int. Okay, and then path name. So the first parameter of our function is the path name, which is the file name, which is the file name or the name of the file, which it will check for all information about it. Struct state buffer. And what does that mean? That means like the second parameter is structure. What is the meaning of structure? We said the structure, it's like an array. And what is an array? Array is like a variable can hold more than one value. But array, what is the difference between array and structure? Array only hold one type of value, which mean like array can hold values from type int. So like a and b and c and d and f and g, but mainly a and b and c and d and f should like have the type int. So int a, b and c and d and f. Okay, but structure can hold many value and many types. Like a structure can hold a char and int at the same time, and double at the same time, and float at the same time. So structure, it's like an array, but it holds different type of values, not just one type. Okay, so we have here struct. And why we need struct here? Because I said state return different information about the file. Okay, if it return different information, that means it will return information from type char, information from type int, information from type size t, information from type like double or float, and things like that. So it return many types of information. So if you have many types of information and you want to save it, uh, or you have it, you should have a struct variable. Okay, so this is the second parameter, and we said that return value will be like 0 on success will be 0, and on error will be 1, sorry, -1. Okay, and let's come here. This is our structure, and we said the structure will hold different information. Like here it holds at the first ID of the device containing the file, and it holds the inode number of the file, and the mode, which type of mode for the file, and also in link, number of hard links, and user ID, a group ID, and the device ID itself, total size, and the block of size of file system. So it has different type of data, and for this different type of data it should have a structure to hold all this data. Okay, Okay, what else? Okay, wait. Now we said that we can just try to like ask our question and try to write the pseudocode, then the code itself. Okay, so our question, which is, what do I need to use this function? And the first thing, we should have our int variable to hold the result from the function, and we have to like give it the path name, so path name, or we can say pointer variable to hold the path name, and of course structure. Okay, struct, uh, we said the structure value. Okay, the structure variable, but like we can, okay, we can just like don't use a pointer variable, or don't declare a pointer variable for path name and just a path name for it, but let's just try to write our steps. Okay, the first thing, int variable to store the result, and second thing, path. If we will not declare a variable for the path name, we just can call the function and give it the path name, and then start the structure. Okay, for okay, maybe we can call the function give it path name, or maybe we just give, let's go step by step and just declare path name, declare path name, and then we have called function, or call the function. Okay, and give it parameters and store of course the result, and checking for error, and then we can access on the struct and ask about anything, but basically we just will print, ask it to like have the access on anything and print it. Okay, and print it, and then we have to like end the program, because just we will write something so simple to declare how to use it. So vi state c hash include stdio.h hash include system, yes, I think state.h. Okay, int main. If we have our path name, sure, path name, okay, we can just say path will be equal to, like we can say task.text, and the int result, and struct state file state. Okay, so we can, okay, call our function. So state will be sorry, the result will be equal to state, and we opened our function. We will give our function the path, and we said path, and the structure file state. It's a file state, right? Okay, it's the path and the file state, which is the structure. Okay, maybe you can, Okay, what I can do? Okay, and result, there's something wrong with it. If what here, result equal 0. Here I'm checking in error but in different way, because I didn't say if it equal -1 do that. I'm just to say if it's 0, that's mean like if it's success, or I did it right. Okay, wait, okay, just write anything here. Okay, if it equal to 0, which is it is opened, sorry, it's like can return the state of the file successfully. We can say file size, we will check on size, will be equal, okay, sorry, percent d slash n, it's d, I think, and bytes and slash n, and then I will copy this here. I will access on the structure, but specifically I will access on specific parameter or specific thing which called st size to get back the size, and I will say printf again. Okay, I will say file permissions, and it will go file structure state dot and st mode. Okay, but I feel there's something wrong. Okay, else here there is an error. Okay, so if there is an error, just like print error, error, and return 1, return 0. So I just created the file, and let's try to compile again, and this is the result. Okay, file size is 27 bytes, and the file permission is okay, so it worked. And we have state and fstat and lstat functions, but 3 of them like do the same thing. It just return back the information, the full information about the file, like we said, maybe the size or the time, like the last time you modify or edit on this file, and the size of this file and the permissions and the name of hard links and the node of this file. Okay, so like 3 of them return the same result or do the same functions. So just basically the only difference between them that lstat specifically like return back information about symbolic link, not the file itself but the symbolic link of the file. But if it doesn't found the symbolic link, it will return back the result from the file itself, like state. Okay, so we can say lstat basically return information about the symbolic link of the file, but if it doesn't find the symbolic link, it will return return the info about the file itself. like state. So okay, state. So now lstate, it's like return the all information about symbolic link. If it doesn't found any symbolic link, it will return the information about the file like lstate. Okay, fstate on the other hand, what it does, it just like return the information about the file descriptor, not the file itself. So it return info about file descriptor, not the file itself. Okay. um, and I think that's it. That is the only difference between three of them, that if you want to return back that information about symbolic link, you will use the lstate, but by the same way of the state itself. So the same way you will use state, it is the same. You will use lstate, and it's the same for fstate. It's depend on what you want. If you want, like we can say here, if you want info about symbolic link, you will use lstate. If you want info about about file descriptor, you will use fstate. If you want info about the file itself, you will you will use state itself. Okay, that is the main difference and the only difference between them. So I will not repeat myself, it's the same code. So just that's the difference, and I think we don't have like much code about both of them. Okay, sorry. And now we will move on the next one, which will be exit function, and I think it's easy. So let's just come here and copy. Exit function calls normal process termination, which means like you are terminating your program or your code in a specific condition. Okay, and you will use the standard lib library. And let's break it down. Void exit here mean like it doesn't return any value, so you don't have to declare anything. And maybe it can take int status, and just let's like go through what is the meaning of int status. Int status here like state you of exist, like is your program is success and you want to end it by success message for the program, or it's a failure and you want to like end it with failure message. And if it's failure, what is the type of failure, and what is the message you want to send. This is like the meaning of end status. What is the status of your program? Is it success or not? So if exit status like if it's zero, if you put like end status, in status you will not declare and define anything for it. You just will write it like exit 0 or exit it's like that exit status exit success. If you write it like this or exit 0, both of those like words or 0 and the exit success, it's a mean that is the end of the program and its success. So the end of the program and it success. So your program is success now. But if you put it like positive integer value, that's like meaning it's end with failure. So you can say end exit uh, failure. Okay, or exit and 1 or 2. And like failure, it's like end the program with failure, and 1 and 2 it indicates specific errors. Like for example, if 1, it's like file not found error. So if you have a file and you are check for this file, and like we can say it will be like that uh, mm, if you are checking for existence of the file, let's say like file equal to -1, that's mean file doesn't exist. Like print error, can't find the file, and exit That means you are ending the program with 1. What is the mean the message of 1? That means the file doesn't exist. Okay. If you have a file and you are checking for the permission of this file and you can't find the permission, so you will print error, can't find the permission. Okay, and exit with 2. What is the meaning of 2? You are sending a message that I will end the program but with error, and this error indication for um, I can't find the permission, or I don't know the permission, or permission denied. Okay, so every number it's indication for something. 0 indication for success, 1 indication for file doesn't exist. um, Maybe we can say here denied permission. Okay, if 2 it's like denied permission, and we still have negative integer value. You can use it for specific errors or code errors or conditions, but basically this is our like most common ones. So I guess exit function doesn't need like any parameter, doesn't return anything, and doesn't it just like basically request you to know what is the status of your program. It will be ended by success or not. So we can just say exit here. Let's look at the library again. This is our library, and we can hash include stdio.h. Okay, and start in the main, and just let's say we have integer x equal to 5, and like I'm saying if x sorry x bigger than 0, print if anything program executed. And okay, just and here exit with 0. Why? Because I'm saying program executed, so it's a success. So if it's success, I will put the condition, or sorry, the exit 0 to indication of the success. But else it mean like our program doesn't success or doesn't work as we want. So like error. Okay, and exit with 1. Okay, program executed, so it ends the program with a success message, because it's success because our x was bigger than 0. Okay, and here we have like hyphen exit, but mainly exit and hyphen exit have the same syntax and same usage and same everything, just like the difference between them in their action. For example, we have something called the flashing buffers, and that's mean like we said here, when we use write or read, like write function or read function, and we want to pass them to memory, they aren't passed like automatically or dynamically to the memory or directly. They are storing at the buffer at the middle, and this buffer give it to or deliver it to the memory. Okay, this is how it's working. So flash, if we say flash, what is the meaning of the flash? Flash, it's like a process to make sure this is things here which we write or we read. It is written here to like make sure that it will send to the memory. Okay, it's not very ugly, so it's okay. Okay, so like our buffer process, or sorry, our flashing process, um, it's like ensuring that we have a buffer, and this buffer have a data, and this data will be transmitted to the memory. Okay, from where? From write or read function. This is the meaning of the flash. Okay, so the basic difference between exit and okay, document between exit and this between our function exit and hyphen exit at this point, that our exit make sure or make the flash process, which mean make sure that we have our buffer, and our buffer have the character to be read or written, and it will transmit it to the memory. But our hyphen exit, it doesn't do that. Okay, so the first difference on something called the flash, and we said flash process is to make sure that you have your buffer, and your buffer have the character to be write or to be written, and it will transmit it to the memory. So exit do this flash, but hyphen exit doesn't do that. Okay, this is the first thing. The second thing is clean up actions. What that means? uh, our our function exit. Okay, second thing in clean up. Okay, what is the meaning of this? Our exit function like have additional clean up actions, which mean like after the exit of the program, it makes sure that if there are files open, or there are stream opens, or every like anything open, it makes sure to close them, and removing like temporary files, and like anything you don't need them after the exit of the program, it makes sure that everything is closed and everything is okay, and it removed every temporary files and everything is okay. Exit function do that, but our hyphen exit doesn't do that. Okay, so like the main difference is just inside their function or their way of work, but the syntax and the status and everything like that, like you are doing, it's the same, and they are the same in this point. But the main difference, if you check, if you want to like close open files and to clean up everything and to make sure about the flash, you have to use exit. But if you don't have to do that, you have to use like hyphen exit. Okay, and now we have our flash function, and our flash function, like we said before. Not here. Okay, like we said before, what is the flash? We said the flash, it's a process of transferring the data, like we said here, the data from um, like the buffer to its destination. So we now have here write or read, and we have here buffer and the destination, like let's say it's in your memory. Okay, so we said that flash function, not our flash process, it's like sending or transmitting the data from here to here. So it's like a process of making sure or scan if already the data transferred from the buffer to the destination. Okay, because we said that the data not come from write or read function immediately to here or directly, but it just come to the buffer, to intermediate or to the buffer, to the destination, then to the destination. So the flashing is to make sure that the data transmitted from the buffer to its destination. Why? Because it's a like greater efficiency in the memory. Okay, so this is like dealing with the memory. So our flash function, what it does, like we said, flash, it's making sure that the data transmitted from the buffer to the destination. So flash function, it is to make sure really that is the data that come from here to here. So basically, what it does, it's just making sure that the data like transmitted from the buffer to uh, the destination in the memory. Okay, so let's just take a look on this and how we can use it. Okay, at the first thing we have f flash, our function name, and we said it's a flash stream, and we said this flash is in process of making sure that there is transmission of data from the buffer to its destination inside the memory. Okay, and it takes cdio.h, and here int flash. Let's say go to return value up on successful completion. It takes 0, otherwise it return error. Okay, so our int flash, um, it's a container for holding the result, and the result is 0 on success, is 0. Okay, that's maybe the first thing we need here. And the second thing is file stream, because you are checking on files. Like we said here int ff flash to just make sure or explain everything. Container to holding the result, we said that on success it will be 0, but on failure it will return EOF. It's like -1. Okay, so it's -1 on error. It's -1 if it's the error, and 0 if it's success. Okay, this is the first thing. Okay, and second thing, it's the file stream, which means it is the pointer to the file, which will be flashed. Okay, flashed. Okay, so it's like pointer to the file. We said it's like a flash and process of transmission of data from one place to another place. So file stream or pointer stream, that's mean it's a pointer to the file which will be flashed. Okay, and here let's take a look for output stream. Flash force a write of all user space buffer data for the given output update stream. Okay, if the stream argument is null, flash what it does, it flash all open output stream. So if our stream, this stream, if our stream equal to null, it just mean it will flash everything, because you didn't specify something to flash, so it will flash everything. Okay, and we said it returns 0 on success and -1 on failure. So I think let's try to write our code. Okay, vi flash.c, and it takes like we said, include stdio.h, int name. At the first, we will just initiate our file and our variable to reserve save the result. So int result. Okay, and file, this the file, and then asterisk. Okay, asterisk file, and okay, file equal open or if open. It's okay, if open, and let's give a name, flash dot text. Okay, and mode of write, I want to write inside this file or file. Okay, so then we will check if file equal to null, which mean I here if file equal to null, it's like an error, indication an error for if open function. So b error, we will try to write the steps. B error, can't open the file, and return 1 as an indication of failure. And then if print f, okay, inside my file I want to write hello hello from. Okay, and then I will put flash for file, and then if print if file again, and world لا okay world C. Okay, and if close file, return 0. Okay, so just let's try to combine dash o flash. Okay, flash. Okay, I didn't have the file, so just let's go back to our flash. It's called flash.txt. Touch. Okay, let's try to compile again. Okay, let's go to our file like lspi, or okay, it's flash dot text. Okay, hello from world C. So it's really right inside our file. And let's go back again to make sure that every step is clear. So at the first, we just declare our variable we need to use this function, which is like result and the file. And I didn't use here result because I didn't check, but of course we will check for error every time. And here I just call open function to open the file by write mode, and here checking for any error, checking for error while opening, and here using if print if function to write inside the file, and here we are making sure that the file is flashed. And here we wrote again, and then we close the file. Okay, this is for flash function, and here it's like our the final function we will take today. It's a kill function, and unlike its name, it's just send a signal to the process. So it doesn't like terminate any process, it just send a signal to a process. Okay, and we have here like these two library, and here it's the int. It has like type int, like as we said, it's a variable or container to hold the result from the function, and the return result will be on success will be 0, and on error will be -1. So because of that we have it type int, and the BID here. Why we need BID? Because if you want to like send a signal for a specific process or send a signal for group of processes, so you have to have your BID of the specific process, or for all or group of process. Okay, so BID like it's a variable. No, it's a variable to hold the PID of one or group of process, and like because you will send the signals for this process or that process. Okay, which mean like if you want to send something, so you will send it for someone or group of people, so you have to have the like the addresses of that someone or that people, that someone or these people, to send it for them. It's like this, like you are sending um like we can say a present or a gift for either one person or group of people. So when you send this present or gift, you have to have their addresses to just like send this to them. It's like that, to have your signal and to have the PID for people you will send this gift for them. Okay, so you have PID of the process to send the signal for it. Okay, and the end signal, and we have many signals. Okay, before signals, we have to talk about PID, I think. Like if your PID is bigger than 0, which means it's a positive number, it's like you are sending the signal to specific process. So here you are sending the signal to specific, okay, specific process. So it's only one specific process. But if it PID it is lower than 0, which mean it's negative number, so that mean you are sending a signal to all process in a group of process. Okay, like there is a group of processes and you are sending the signal to all this group. Okay, so the negative number, you are sending a signal to all processes in a specific group. So like it's looks like if you go back, okay, home. Look, it looks like this is a group of negative of process, and like you have many process there, and when your PID is negative, so you are sending a signal for a group of process. So your signal will come here. Let's say your signal is red, so signal will be here and will be here and here and here and here and here and here. So if your PID is negative, that means you are sending a signal to a group of process. Okay, but if your PID equal to 0, so like you are have a group of process inside your main process and you are sending signal to them, so your signal will be here and here and here and here also. Okay, so if it is positive, you are sending your, like if it's positive, you are sending to specific process, so it's only one unique process you are sending the message or the signal to it. But if it's 0, you are sending the signal to all processes of the group of the call process. Okay, so you are calling process, it is the leader of the group, so you're calling process here, it is the leader, and you are sending all messages or all signal for like the child process here. Okay, but if it's like negative, you have a group of processes and you are sending this is messages or this is signals to this process. Okay, and that is the mainly difference, or the mainly difference between PID equal to 0 or bigger or lower than 0. So let's go to our signals. We have like many signals, like signal term, which like you can request termination of the process, or like a signal which we had before, it's control C, and signal kill to terminate a process, or signal stop to like suspend or stop the process, and the signal user 1 and user 2 to identify or to define signal for custom purpose for the user. And like you have many signals, and there's a list of them. I think they are here too. Anyway, it's okay. Okay, and we said the returned value will be like 0 or -1. Okay, and you can write wait, we can say kill minus L, right? Yes, kill minus L, it's like listed for you all signals you have. So you have signal hub and signal end, and like you can search about all of them. Okay, so it's a command called kill minus L. Okay, so let's try to write a code. um, okay, so basically before writing the code we said what we want to use this function. What do we need to use this function? The only thing we need, I think, is BID of the group, and just it. So let's try to make the steps. First, int BID. Second, get BID. You have to get your BID to like make the process or the signal, change the signal on this BID. We can print the BID. Okay, I just will print the BID, and then I will call the kill process. So I will call the kill process, so we have to declare a variable to save the result returned back from kill process, and then we will check for error, and then okay, we check for error. If there is an error, we will print an error. If there is no error, I just will say print the signal sent successfully. Okay, let's try to make the code VI. I think it's called, no, it's a kill, not signal. Let's see, and okay, okay, system type and signal. Okay, and hash include stdio.h and hash include unistate.h. Okay, and hash include stdlib.h, stdlib int main. Okay, main bid of t equal bid. Okay, sorry, bid of t bid equal get bid. Okay, now I get the bid of the process, so print f my bid is sending sector to myself. We didn't okay, now we have to call the function, so we have to make int result. Okay, result will be equal to kill function, and I will give it the PID, and then the signal, so it's signal term, and we will check if result equal to 0. 0, that means it's successfully sent it, not error. So printf success signal sent successfully. Okay, and else print error, and we can use exit with exit failure, FA clear failure, FA failure. Okay, and return 0. Okay, my PID is, and sending signal term to myself and terminate it. Okay, so this is just the all functions we have today, and I think we end all system calls and function in simple shell. So that's all.